Everybody, in this video we are going to start a new chapter. We're looking at chapter 11 and it's going to be on some 3D shapes. So they call them space figures, and we're going to talk about nets a little bit, and we're going to talk about cross sections. So let's jump in. The first couple things we need to do is just a bunch of vocab. So polyhedron is a 3D figure whose surfaces are polygons. So they could be like rectangles or triangles or a hexagon, something like that. Then on a polyhedron, you could talk about a face. So a face is basically a surface. So like this is a face in the front here. This whole thing, if you were to fill all this in, that's a face. So we'll say a polygon surface. And we also have edges. So an edge are like these segments going around our shape that connect all the faces. So an edge is a segment formed by the intersection of two faces. And then last up on there, a vertex. A vertex is essentially going to be each of these corners here. We use vertex a lot in a lot of our different concepts that we cover in geometry. But vertex is a corner point. Some other vocab that you need to know, and this will be useful for an activity you're going to do very soon, is distinguishing between, like in our categories of our 3D shapes, a lot of them can fit as either a prism or a pyramid. There's also like spheres and cylinders, but a lot of them can fit in these two categories. So a prism example is what you see right here. It's going to be a geometric figure with two congruent and parallel bases. So if you look carefully at our picture that we have here, this would actually be considered a base, and that is a hexagon. And then if you see a like down below that would be parallel to it, like they'd never cross if you think about it as a plane going on forever and ever. Exact same size, also a hexagon below. So bases doesn't necessarily mean, a base doesn't necessarily mean it's the bottom of the shape. And we saw that with trapezoids, like we had bases, depending on how it was turned, they were always the parallel side. So same kind of idea. When you name a prism, named by its base. It's named by its base. So like I mentioned before, these are hexagons. And so if I was to name this, I would call this a hexagonal prism. Hexagonal prism. So that's one category. Another category for us is a pyramid. So I always remember that a pyramid essentially comes to a point somewhere along the way. So that's a pyramid. This one doesn't have like that one point it comes to. It has those bases that are across from each other. So a pyramid is a geometric figure with one base. Some things to note here. The sides are triangles. The sides meet at a common point. So that's talking about that point that everything goes up to. These are also named by its base, so whatever is on the bottom. So for example, this one actually has a base that's a triangle. So we would call this a triangular pyramid. Now maybe that's kind of confusing because the base is a triangle and the sides are also triangles. Let me see if I can, I'm not the best artist, but let me see if I can draw something else. Like, let's say we had this as our base. So notice that this pyramid still has the triangles as faces, but the base is a square. So we would call this a square pyramid. So what you're going to do is you're going to pause the video in just a moment, and you're going to go to the activity that you can find in Google Classroom under the Classwork tab on Prisms, Pyramids, and Nets. So let me show you what that looks like. So there's 2 slides that you have to interact with. So the first slide is asking you to categorize these shapes over here. So something I noticed, like this guy is a prism because it has those 2 parallel bases that are across from each other, like the bottom is a triangle and the top is a triangle. This guy is a pyramid because everything comes to a point. It has that polygon base, but then the sides are triangles. A cylinder reminds me of like a can of soup, so this would be like a cylinder. And then a cone looks kind of like a pyramid, but the sides are smooth like that. So you are going to try this out in Google Classroom, and I will take a look at these when I come back. So get those all sorted out. The second page is asking you to see if you can come up with the name for each of these. So again, the names of pyramids and prisms are all revolving around the base that it has. So for instance, this shape right here is actually a prism because it has a pentagon here and a pentagon parallel to it across the back. It's not sitting on its bases. You can imagine tipping it up so that it would sit on its bases. But because the pentagons are the 2 shapes that are congruent and across from each other, we would call this a pentagonal prism. And let's do a pyramid one. Do this guy. Looks like that has 1, 2, 3. That has 5 sides for the base, so that's going to be a pentagonal pyramid. So go through, try those out, and I'll take a look at them when I get a chance. See if you can name all those shapes. I got to erase my work so that when you guys get the form, it isn't done for you. So jumping back to your notes, make sure you try out the activity. Let's go through and see if we can identify the number of vertices, edges, and faces in this particular pyramid, this polyhedron. So vertices, I'm going to use a capital V to represent that. That's just the corners. So 1, 2, 3, 4, 5. Edges, we'll use an E. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, faces. That's the number of surfaces that it has. So 1, 2, 3, 4, 5. Hopefully that's pretty straightforward. What I'd like you to do is I'd like you to try out these different polyhedron, list the number of faces, the number of vertices, the number of edges, and then try this little formula here. This was discovered by a guy named Euler, is how you pronounce it, not Euler, but Euler, very famous mathematician. But see what happens when you take the number of faces plus the number of vertices and you subtract off E, the number of edges. So pause the video, try it out. All right, welcome back. So first one, number of faces should have been 6. Vertices is 8. Edges is 12. So if I run this little formula, 6 plus 8 minus 12, 14 minus 12, you should get 2 out. Next row, faces, 1, 2, 3, 4, 5. Vertices, those are all the corners, 6. Edges should be 9. We'll do 5 plus 6 minus 9. That gives us 2. Last one, faces, 7. Vertices, 10. Edges, 15. We'll do 7 plus 10 minus 15. That gives us 2. So as you can probably guess, this is what Euler discovered, that when you take the faces plus the vertices, you subtract off the edges every single time, you get 2 out for an answer. Now, this is not actually the way the formula is like presented. Like if you Google search like Euler's formula, most likely how they'll present it to you is faces plus vertices equals edges plus 2. So we had f plus b minus e, like we subtracted that over, so every time you could see that it gave you 2. But this is usually the way it's presented. So that's how I'm going to use it moving forward. Or f plus b equals e plus 2. So look at some more complicated polyhedrons. All the faces are some kind of polygons. This guy has 20 faces. We need to figure out the number of edges and has 12 vertices. So I'll just break out my little formula here. Faces is 20, vertices is 12, edges we don't know, plus 2. On the left-hand side, that's 32. We'll subtract the 2 on over. So edges is going to come out to equal 30. Why don't you try the next one? Pause the video, see if you can get the right answer. All right, welcome back. So we got faces plus vertices equals edges plus 2. Faces we don't know. Vertices is 20. Edges is 30. We will subtract the 20 over, and we'll end up with 12 out for an answer. So really not that hard of a formula to use, especially when you don't have to count these things. They just tell them to you and what you need to find. Some other stuff about 3D shapes that kind of goes together. Where we're headed in this chapter, we're eventually going to have to find like surface area and volume of our polyhedron, our space figures. So nets. Now I know at the very beginning of the school year, it might have been like day 1 even, or day 2, we talked about nets. So basically if you take a 3D shape and you cut it open and lay it flat, so it's 2D, that is what a net is. So maybe a little bit better explanation. A net is a pattern that folds into a 3D figure. So you have to imagine each of these down here. If I was to fold them up, what would they look like? This first guy, if I take this point and I fold it up, take this one, fold it up, fold it up, fold it up. Hopefully you can imagine that that's going to end up being a pyramid. It's going to come to a point. And the bottom of that, I mean, it should really be labeled better, but I think it's okay for us to assume that that's going to be a square. So we will say square pyramid. Part B. So imagine folding this up. This comes up, this comes up, this comes up that side, this comes up that side. So it's not coming to one single point like this one did. You're going to end up with 2 polygons that are across from each other exactly the same. They'll be congruent and parallel. So this would be considered a base, and this one is considered a base. So this is actually a prism, and because the bases are triangles, we'll call it a triangular prism. Part C, imagine folding that up. So we've got circles like as our bases that'll be across from each other. And then this rectangle piece that will kind of fall along the edges. So this is actually going to be a cylinder. Last one. Fold this up, fold this up, fold this up. Everything's going to come to a point. Your base is a triangle. That tells me that I have a triangular pyramid. Pyramid because it comes to a point. One more topic I'd like us to look at is called a cross section. So basically you'll have some kind of solid, 3D solid, and you have to imagine if you could cut a really, really thin slice off of that solid, like what shape would it be? And we're just talking 2D shape. What would that shape be? So here, this is a prism. It's a triangular prism because this would be considered the base and the other triangle back here. And they have like this rectangular piece that's coming through and cutting it. And so they're trying to show you that the cross section, if I could just slice a little bit off of that, a narrow slice of that, it would end up being a triangle. Let's get a definition up here. Cross section is the intersection of a solid and a plane. Not an airplane, a flat surface plane. Looks like we got an animation here. Let's follow that. That looks like fun. Oops, that's not what I wanted to do. Okay. And I can link this in your Google Classroom so you can play around with this. But it helps you kind of imagine what all these different kinds of cross sections are. You can kind of see by just looking at the pictures. But like, if I grab this guy, this is a rectangular pyramid because it has a rectangle base and it comes to a point. I guess we're going to start over here. And I can move this. This is a plane right here that's cutting that. And I can move that plane around. So you can see the whole time it's like some kind of rectangle. At one point it might become a square as it goes through. So if someone's like, hey, what's the cross section? You would say, it's a rectangle. Let's do another one. What else we got here? Cylinder. Move this up and down. The cross section is a circle. You can see how it's highlighted in here. Got anything more fun? Sphere. Ooh. I think there's some other things that are going on here, but you can see that that cross section as we move it is a circle. So I'll link that. You can play around with that. It helps you visualize kind of what we're talking about. Let's try out these last couple problems here. So number 4, it says describe the cross section of this hexagonal prism if we went horizontally. So if I was to cut it this way across, just like what I was doing in this animation, these are all horizontal cross sections. So hopefully you can see that that's going to end up being a hexagon, because it's just going to come in. Ooh, it's not a very good hexagon at all. I feel like it just got worse. Okay. Something like that. Now imagine it vertically. Let's see if I can go back to this. I wonder if I can change. These are all horizontal. Ooh. Oh, we can go at the side. Hey, look at that. That's pretty cool. So now the cross section is like an ellipse shape. Now the cross section is a rectangle. Kind of forgot about that. That's cool. Play around with that. So imagine if you were able to come in here vertically and what shape you'd get out. Probably some kind of rectangle. Just come in like this. It's a cylinder. We were just playing with the cylinder. For the vertical, my cylinder, it is a rectangle. Horizontal, go back and look. Circle. So kind of a bunch of random stuff that's about 3D shapes, vocab, cross sections, nets, all that good stuff. So that concludes the notes for today. Please make sure you fill them out, keep them for an upcoming quiz, and then also do the individual Kahoot and the worksheet assignment. Thanks for watching.